There's a lot of Jeffs. Like, how many presentations have been Jeffs? And then every time somebody comes up and they say, oh, when Jeff talked about this, you're going to have to start adding an initial or something, because there's two more Jeffs. So yeah, thanks for having me. We are going to talk about field installation best practices. So very quickly, we do want to talk a little bit about who the industrial group is, give everybody a bit of an overview, and then we'll jump in. So the RPS Industrial Group, we are a group of collective companies. We work for all those industries and markets and whatnot that Jeff just mentioned, a host of different companies. It looks like a little bit of a dog's breakfast of companies, but really what kind of joins us is that we have a business model that arches across all of the different companies. Typically, we are in a situation we are designing, building, installing, managing an asset from start to finish. We like to say that we hire the experts in our fields, and then we support them with as much data as we can possibly give them. So how do we build out data capture processes, analytics processes, and then support our industry experts with that information to then be able to go out and really provide what we like to say is act as strategic advisors. So that's what kind of keeps our group together. So what makes us strategic advisors in field services in FRP? Well, the founding company of our group was RPS Composites, which I think many of you are probably familiar with. And we've been doing this for quite a while. RPS Composites has been in business for 50 plus years, and we do have operations all across North America. So I want to start with just a very quick story on what not to do. So we were called, this is probably 4 or 5 years ago, into a power utility company who had just completed a cooling water project. They called us because they had failure on startup. And so we got a team together and we said, sure, we'll go in, we'll have a look. We went in and they showed us a very large riser. I don't know the exact diameter, but I know it was big, where upon startup, it had fractured at the joint. Upon further inspection, we saw that the joint was very, very small and had slid down the pipe. So there was very little overlap at the joint itself. So upon startup, out comes their cooling water and they're in trouble. So as we inspected it, the customer starts to get worried and says, you better start taking a look at everything else. So we inspected all of the joints and found 250 joints that needed to be replaced. So we went through that process, and then we asked them, well, would you like us to look at the rest of the system? They said, no, I think we're good. You guys go home. We don't want to know anything else. So we did, and they ran for about 4 months and decided to go through a shutdown process. And when they did, they realized that during drain down that they hadn't designed their pipe for vacuum, and all of their risers started to implode. So we had to replace 20 plus 20-inch risers on top of that. Come to find out, they had procured their pipe offshore without any real consideration on design, and they had found a local boat builder who they thought would do the installation for them. And so as you can imagine, I know the counterparts are all laughing because I'm sure we've all seen this before. This was a company that had FRP within their plant. Probably a new engineer or somebody, a maintenance person, who thought that they were going to save the company a bunch of money, and it didn't work out that way. So we as stewards of the industry, our hope is that asset owners select good vendors, right? Good providers, good fabricators. It doesn't have to be an RPS. There are some great suppliers in this room, but doing so can save big issues on situations like that. So designing for success. This is something that always gets overlooked, the actual installation. It'd be great if we could just snap our fingers and your system would all be in place. but it never works that way. If you have the right spec, but the wrong pre-planning and consideration for installation, you'll probably fail in the execution of your project. Installation is a huge part of any asset life cycle. So if you don't take it into consideration, the project could be considered a failure, maybe just in overrun, over budget of the installation itself, or actual failure of the asset. So of course, always working with your vendor in terms of things like determining service and whatnot, but I mean, there's been a lot of discussion around that, so we're not going to get into big detail. Sometimes there's opportunity to choose off-the-shelf products. Now, rarely do we have products on the shelf, but off the shelf meaning there may be some pre-design and things like that that can not only help with the lead times, cost, but it actually can help with the installation as well. So from our perspective, these are three of the things that there's a whole host of things to take into consideration. These are three that sometimes get overlooked or not taken into consideration and can have a big effect on your project. First, and this is all in the design phase. Jeff's going to talk a little later about the actual on-site, what to do, what not to do, and whatnot. But this is really right from the design phase. So, how do we support the system? If the actual installation is not taken into consideration, and all of a sudden you have a support or a joint that lands on a support, not taking into consideration diameters and whatnot. How do you make those adjustments in the field? The more you can take that into consideration prior to getting out there, the better the project will actually flow. Thicknesses are never standard, so make sure you're talking to your fabricator prior to what is the thickness of the pipe going to be. Just because you have an ID, again, everybody in this room knows this, but doesn't mean that the OD is going to be standard across the whole system. Field joints. So again, talked a lot about joint failure this morning and this afternoon, which is great because of course that's where we always see the issues. We need space to do joints. You can't, tuck it into a small corner or there's several other pipes or it's leaning up against the tank. We can't do a proper joint. So we need space. That needs to be taken into consideration during the design phase. How do we get at that joint in the field? And probably, the thing that we find can save the most money, the most problems, the best field joint is the one that you don't have to do. So anytime that you can take a system, and again, ourselves, our counterparts in here, we're very good at taking a system and saying, how do we break it down into spools so we can do as much of that work off-site as possible. The fewer field joints we can have, the better. So looking for those opportunities to build out spools that can fit on a 40-foot trailer, bring those to site, do those installs. The more we can do that, the more we will save you money, time. You can plan for your time on site. So this is just a very quick cheat sheet that we put together. I'm not going to go through it, but probably, again, the most important thing, availability. This is typically not off-the-shelf product, so think ahead. Think ahead in terms of planning and whatnot. How are you going to procure this product? Dimensions, designs, all of those sort of installation difficulties and whatnot. It's all different from steel. So please take those things into consideration when doing orders. QA considerations completely different from a steel product as well. So one thing that I think people often don't take into consideration when planning sort of an outage or an installation or whatnot is how long it actually takes to do a field joint. So this is a very quick rough table that I think, Jeff, is this provided to everybody? Yeah, which is great.
The presentations are on the flash drive in the bag,
so this would be our P150 product line, but it would be very similar for many products. Of course, there are variations depending on resin type and thickness and whatnot. But for the most part, this is a good rule of thumb for FRP product. But as you can see, it takes quite a bit of time and labor to put in a field joint. So if you think about a large system and, Daryl broke down, some spooling and whatnot and said, look at how many joints there are. This is what it typically takes to do a field joint. And then if you take dual laminate, now it adds a whole other level of time and complexity, right? And an additional inspection point. So, this is really, as you're starting to plan out your shutdown prior to, start to think about how much time the field joint folks will take on site. Quite often we end up being critical path as we go through this, or a bottleneck, right? So I'm going to turn it over to Jeff, and he's going to actually talk about what's going to happen on site.
I haven't been doing fiberglass long. I got a 26-year career in oil and gas, so I've only been doing fiberglass for about 3 years, but I've done field service and operations management for a long time. So anyway, we'll go through this real quick. If you got questions, just let me know at the end, and we'll have time for that. All right, so first consideration is the right team for the job. This has already been talked about extensively this morning. I think Daryl brought it up about installers, about having qualified people, and I think somebody else brought it up too with Ineos. I can't remember his name. Bob, maybe? Oh, Bruce, yes. There he is, Bruce, yeah. So not all FRP installers are qualified, so make sure you're finding and selecting people who are qualified to do your FRP installation. That goes from field joints to flange installs. I can't tell you how many job sites we go on where general contractors do FRP flange installs and half of them are cracked. They just over torque them. So make sure you're selecting the right people for the job. So bonder welding certification, that goes for both FRP and dual laminate. So there are certifications. Most of the vendors in here certify their laminators and their thermoplastic welders. So make sure those guys are certified before you select them. Experience is a big thing. Selecting a shop, we talked about that earlier, that was mentioned. You go in a shop and there's a bunch of 20-year-olds in there, that might be a red flag. So fiberglass is an art. These guys are certified, they've been doing it for a long time, and they just know what to do. They know how to mix, they know what resins go well, they know heat stress that goes on these joints. So longevity, guys who've been doing it a long time are your best bet all the time. Health and safety, look at records. That's a no-brainer. Product scope, familiarity. Has that vendor done your type of project before? Try to get some information from them and say, have you done this type of project before? Have you installed this type of pipe in this type of plant, so on and so forth. In-house support. Again, most of the vendors in here that do FRP have that type of support. And we're talking about engineering, design, safety. Somebody that if you're in the middle of your project and you have an issue and you've got to change an ITP or something like that, your person who's doing your install has those people in-house that they can pick up the phone and call them and support them. Maverick is a good support too also. So site leadership team, depending on project size, again, that goes back to support. Some FRP installers don't have that support. They don't have project management teams and those type of people that can support larger projects. And then of course availability. When you're talking about experienced fiberglassers, they get booked quickly. I can't tell you how many times we get calls from clients saying, hey, we've got 2,500 foot of FRP to install and we need it done in 2 weeks. Probably not going to happen. If it does happen, you're probably going to get some not qualified people out there to do it. So plan accordingly. Make sure you understand all of these things when you're going into the planning phase of your project, and take those into consideration when you're looking at it. So collaborate with your installation team in on-site planning phase. On-site planning phase. So work instructions and ITP. Can't stress that enough. Most people know what an ITP is. If you don't, it's basically it's a test plan. It is what we follow on 99% of our projects. Hold points, review points from when we're doing these installs. We're making sure that we're doing them in accordance to what the requirements are of the project. So make sure to establish that up front. Discuss scope with your supplier and your contractor. So as you're ordering and as you're planning your project and putting all this stuff together, start discussing with whoever's going to put that in, who's going to do your installation as early as possible. Don't wait till the last minute. The more they know, the better off they can support you. Steps in the scope to be completed by others. So this is a big one. A lot of times you don't have one person doing everything. There's multiple contractors on site. So make sure all of those people, you get them all together and you discuss that up front, discuss the project and how it's going to work, because there's gaps there. And if you don't find those gaps, it's going to stop your project. So get all the stakeholders together very early, do the best you can with that. Make sure everybody's on the same page before you get to installation phase. Project schedule, that's a no-brainer. Everybody does schedules in here. They know what schedules look like. So make sure you've got a good schedule, and make sure you include your installer in that schedule. Hey, how long is it going to take? Which is another reason why we kind of supplied the baseline for how long field welds take, kind of give you an idea of what it, put that in your schedule when you're scheduling. Critical path, again, it goes back to scheduling. Jeff already mentioned that a lot of times installing fiberglass turns into critical path, especially on larger projects. It's very time consuming, but that's what it takes to get a quality product. Let's see, critical task. So that goes into scheduling as well, but there's critical tasks throughout the project that are going to take time, that you may not have all the information on. Try to identify those and highlight them early in the project. Discuss that with your installation team. Say, hey, we may run into a problem here. Let's start thinking about it as we get close to it. And then don't assume anything. If you assume something's going to mess up almost 100% of the time. So when you hire a subject matter expert to do your install, they're there to support you. If they're not, you probably brought the wrong people in. But ask questions. Don't be afraid to ask them questions. They've probably seen it before, and they can probably get you the answer and get you where you want to go before you spend time digging into it to try to find it. So we're still at the pre-execution phase, but this is probably just before execution. So material and equipment on site. Probably shouldn't have to talk about this, but we are going to talk about it. 2 weeks, 3 weeks, 4 weeks before you start install, get your supplier out there, your installer out there to look at the material, to make sure that everything has arrived and you got everything on site. You don't want to get halfway in your project and realize you're missing parts and missing components and you can't find them, and then your project's basically stopped and you've got to, recover from that. So identify changes in any safety hazards, risk assess those, make sure you understand. Just because you planned it with certain risk doesn't mean that those risks are still the same when you're ready to do the install. Things may have changed in the plant, things that may have changed with your supplier, you may have changed, where the lines are going to be ran. So make sure you risk assess that right before you start the project. Go through it again, make sure all the hazards are identified. That goes back to the safety aspect. And I keep looking on this side because I can't see that side. I don't know why, but that one looks blurry to me, so I'm just going to keep going over here. Permitting requirements. Every plant does permits differently, every single one of them. So make sure that your supplier and your installer knows what your requirements are for permitting processing inside your plant before they get on site. Because that's 2 to 3 hours a day hold up almost all the time. You're waiting on a permit to go to work. So make sure they understand those and try to mitigate that the best you can. Project deliverables, and again, ITP hold points. So you've written an ITP, your supplier knows the ITP, you know the ITP. That doesn't mean your installer knows it. So make sure and go over that with them again prior to the install and say, hey, when we get to this point, it's a hold point. And then tied in with that, make sure that they understand when those hold points are going to happen, and they're letting you know 2 to 3 days before. Say, hey, we're going to have a hold point on Tuesday. Make sure they understand that. Okay, give me 24 hours or 48 or whatever it is you need to say, we got to have a hold point. That way I can get somebody out there So many times we get on projects and we get to a hold point and we sit around all day waiting for somebody to show up and say, oh, well, we ain't going to get to you tomorrow. And that's just days eating into your project and just, costing you more and more money. Stakeholders, highlight SIMOPS. We talked about that already, but make sure you understand what's going to be going on around you. Most of the time, an installation is never done. You're just going to install one fiberglass line. That barely ever happens. There's always other things going on in the plant as well. So make sure your installer understands what other operations are going on around them, things that may hold them up. And that goes back to talking about, hold points and, safety risk and those type of things. Is there going to be crane operations going on? Is there going to be demolition going on? Are there going to be welding somewhere where you have to shut down? Resin is flammable. So you can't be welding right around where you're trying to do field welds. Job QA/QC documentation. Let your supplier and your installer know up front at the end of the project what quality documents you're going to require. Most of these installers already have a set of documents that they're going to provide at the end of a project. Weld maps, gel testing, those type of things, and we can get into detail with that. If you got questions about it, come ask me and I can talk to you about it. But you may have something different that you want to see at the end to verify that it's been done correctly. Identify that up front so there's no backtracking. They can do that as we go through the process. An achievable, manageable equipment layout plan. Where you're going to put all the equipment at, where's your installer going to set up at, those type of things. Sometimes we go out and we're working on this block of the plant and they want our trailer to go 2 miles down the road. That's not efficient for anyone. So make sure you come up with an equipment plan. I know it's a lot of information, but it's important. All right, weather conditions. So this goes back to your question a little earlier. Time. FRP and resins react differently in different temperatures and different humidity, but there's standard guidelines we try to stick with. First off, your PSA, when you do a pipe stress analysis, which you should be doing on any large installs, and Maverick will tell you the same thing. Whatever temperature that PSA was designed for, kind of understand when you're going to be installing this pipe so you can design your PSA based off of what the rough temperature is around that time of year. So if you do a PSA and it's designed around 90 Fahrenheit and you try to install this stuff in the wintertime, it's going to be totally different, right? So you're going to design a PSA and you're going to install around that same temperature. So understand that going in up front. Roughly 90F is the ceiling for doing FRP field installation, which is why people don't do it around summertime, especially in the South. And then anything under 50F, special considerations have to be put in place to do fiberglass install under 50F. 90F, you'll cause overheating of joints. They'll overheat, they'll overcure, they'll burn, which will cause a failure. And then under cold temperatures, some resins won't cure properly, and you've got to post-cure them and heat them up to get them to cure. So that's also considerations you need to take in. The next thing, weather. Maverick's already touched on this. Glass does not work well with humidity. As a matter of fact, it ruins it. So anything over 90% humidity, we don't do field welds unless we bring in a dehumidifier to try to take the humidity down. Cannot see rain, cannot see moisture. This stuff gets moist, it's destroyed. So you got to take that into consideration when you're planning as well. Nobody in here is a weatherman, so you do the best you can with what you have, but you got to plan accordingly. If you're going to store large amounts of material, and you try to make sure that they're stored outside, out of the elements to preserve them. A lot of times when we do our field weld kits, they'll come from the manufacturing. They'll all be in a sealed, sealed and pressure sealed, so they can't get damaged. And to use it, you open it, right? So that's consideration as well. I think I got all of those. Yep. Again, you can bring in dehumidifiers in some cases, but it's very rare that actually works. So just be cognizant of that. All right. During installation, the quality, again, ITP. Talked about ITP multiple times and continue to talk about the ITP. Make sure the ITP is number one, achievable, it's agreed upon, and then stick to it by all means. Make sure your supplier is sticking to your ITP because that's your governing document for your install. And I'm not going to go through all the points. Everybody knows what an ITP is. Inspection of laminates. So again, we talked about storage of glass kits to keep them out of the weather. Verify resin. So everything NEO sends out the door resin-wise has a certificate of conformance with it and a batch number. So those should be readily available and accessible for your install team. Whatever resin they're using, they should have all that. That should be recorded for every field weld that they do. It's called weld mapping. And then your batch numbers and expiration date of the resin as well. So resin has an expiration date. If it's past the expiration date, we don't use it. And then I talked about resin testing, that's gel testing. So we do that every time we open resin to make sure that the resin still reacts properly with the catalyst before we use it on a weld, on a joint. Peel test. This is more for older FRP than new installs, but if you have, if you're trying to, say, add a nozzle to a tank, we've talked about that. If the tank is older than 6 months old and you want to put a nozzle on it, we'll come in and do a peel test. And basically what that says is that the resin that we're using will bond to the old material. And if you got questions about that, again, you can come ask me about it. I'm not going to tell you what it is, but it's basically a bond test to make sure you can bond to old fiberglass. And then there's primers. There's primers that can be used to assist with that bond. All right. We talked about weld maps already, so those should be done by your installer, and then that should be submitted at the end. And then bar call testing. That's the last thing we do after a field weld is done. Once it's cured, we do a bar call test on that to verify that the hardness has been achieved. Every resin type has a hardness rating that it's supposed to hit. So at the end of that field weld, once it's fully cured, we'll bar call test that to make sure that the hardness has been achieved, and that's kind of the last check in the box. And then any questions, contact the manufacturer. Don't hesitate to make phone calls. I mean, your manufacturer manufactured that pipe a certain way, and the field welds line up, or should line up, with the way the manufacturer did their manufacturing. So if there's any questions, contact them. All right, last thing, turnkey. We talked about this a couple times this morning already, and even it's in this afternoon. Make sure that if you can, select a supplier that can engineer, design, manufacture, and install all in one go. That's always your best bet. You eliminate gaps, you eliminate communication difficulties, you eliminate trying to install a product that your installer is not familiar with, or vice versa. We talked about flange differences, all those type of things. So your connection points inside your process. That all greatly reduces if you have someone that does everything. So again, system design, processing, advisement, manufacturing, installation, inspection and maintenance. That's critical throughout the life cycle of your system. And then end of life replacement. So every system has an end of life. It should be designed for an end of life. You should know when that end of life is supposed to hit, and select someone that can help you through that to make sure that your system is working correctly and it's going to reach its end of life. And if it can't reach its end of life, why? Try to figure out the next steps for your replacement.